As military velocities have accelerated into the supersonic regions, the Department of Defense has sought a highly precise positioning, velocity, and time information system that would enhance navigation and weapons delivery systems for global land, sea, and air operations. With the advent of the space age and its attendant technologies, such a system is now practical. It is known as Navstar, Global Positioning System, GPS. The name chosen for this new system points out two of its major features: global, continuously available, worldwide, to authorized users, and positioning, implying more than simple navigation. The Global Positioning System can pinpoint an aircraft, land vehicle, or seagoing vessel within 10 meters of its actual location in longitude, latitude, and altitude. In addition to Navstar's extraordinary positioning accuracy, it can measure a high-speed aircraft's velocity within less than a meter per second and provide synchronized time accurate to better than a millionth of a second worldwide. GPS is the product of a joint program office with participation by the Army, Navy, Marines, Coast Guard, Defense Mapping Agency, and member nations of the North Atlantic Treaty Organization. Managed by the Air Force Space Division for the Department of Defense, Navstar evolved in 1973 from the Air Force 621B and the Navy Timation programs. This global positioning system offers specific operational advantages and the possibility of tremendous cost savings. A satellite-based radio navigation system, GPS consists of three segments: the space segment, the control segment, and the user segment. In the operational space segment are 24 satellites which complete 2 revolutions of the Earth per day in 10,900 nautical mile orbits. Carried aboard each satellite is the key to the Navstar system, an incredibly accurate and stable atomic clock, stable to 1 second in over 300,000 years. A 12-element shaped beam helix array antenna continuously transmits L-band navigation signals on 2 frequencies to cover the visible surface of the Earth. Each satellite is identified by its own unique code on the transmitted signal, while continuously broadcasting its precise position, time, identification, and other information. But until the system is operationally deployed, a smaller test constellation will be maintained. The test satellites are nearly 9 feet tall and weigh 950 pounds each when in final orbit position. The main body cross-section measures approximately 3 by 3½ feet. The 2 solar arrays, continuously tracking the sun, supply the power and are backed up by 3 nickel-cadmium batteries for operations when the satellite is in the Earth's shadow. The satellite is designed for a minimum orbital life of 5 years, but carries sufficient expendables for 7 years. The satellite is 3-axis stabilized by 4 reaction wheels, 3 orthogonal and 1 skewed. A hydrazine propulsion system provides thrust for station keeping and attitude control. The control segment consists of widely separated monitor stations, the master control station, and the upload station. Located throughout the world in U.S. controlled territory, the monitor stations are augmented pieces of user equipment, including a relatively simple omnidirectional antenna, an atomic clock, and a computer program package. The monitor stations track the satellites and extract ranging data from the navigation signals, which are transmitted along with satellite state of health information to the master control station. The Master Control Station is located at Vandenberg Air Force Base during the test phase. It corrects the data for transmission delays caused by ionospheric, tropospheric, and relativistic effects to compute the best estimate of future satellite orbital position as a function of time. The Master Control Station also corrects the orbit prediction for velocity and acceleration due to solar pressure variations, and determines satellite clock time relative to system time. The data generated by the Master Control Station allows synchronization of satellite clocks to within 1 nanosecond, 1 billionth of a second. The upload station delivers this synchronization information, orbital prediction, and other data daily to each satellite's memory. The satellites then retransmit the data to the users. The third segment, the user segment, is the reason for the existence of the other two segments. The user equipment includes 20 to 30,000 military user equipment sets, each consisting basically of an antenna, a receiver, signal and data processors, and a control display unit. By emphasizing modular design, a user can tailor receiving equipment to his specific requirements at the lowest possible cost. The modular design facilitates maintenance, repair, and integration with other systems, such as an inertial navigation system, to keep the INS precisely and constantly updated. The specific modules to be integrated into a particular user's equipment are dictated by his accuracy requirements, dynamics, and sophistication of his associated equipment. High-performance tactical and strategic aircraft demand a maximum performance package of Navstar modules. Other aircraft can be fitted with less costly equipment about the size of current TACAN receivers. With appropriate packaging, the low-cost set can become a marine navigator, satisfying shipboard environmental conditions. Using large-scale integration technology, a compact receiver weighing less than 20 pounds can be mounted in vehicles or carried by foot soldiers. The result is that an unlimited number of users can obtain position, velocity, and time information that is precise and immediate. The user's equipment is designed to select the signals from the 4 satellites of the 6 to 11 always in view that will provide the best navigation. Ideally, this would be 3 satellites equally spaced around the horizon and 1 directly overhead. Since the GPS concept is based on knowledge of the precise position of each satellite as a function of time, the control segment continuously predicts each satellite's orbital position and keeps its clocks synchronized. Because the data is tied to a worldwide common grid system, all users can compute their positions and velocities in the same reference frame with an atomic time standard available worldwide. Navstar's service is continuously available at any point on Earth or in near space and can be used in all weather conditions. The user is passive. No transmission is required from the user to interrogate the satellite. Therefore, the Navstar GPS can support an unlimited number of users. This one-way only operation also permits the user to gather positioning data from the system without revealing his position to hostile forces. The integrity of the received signals is increasingly assured because of the high jam-resistant receivers being produced by advancing technologies. Every service has a definite need for the global positioning system. Army and Marine ground force missions include positioning mobile artillery, locating targets, and coordinating with Air Force and Navy units during joint operations, particularly in close air support and rapid combat surveys. Fleet ballistic missile submarines and other seagoing launch platforms can benefit from precise positioning. Important applications are seen for anti-submarine warfare, and harbor control, including locating buoys, shoals, reefs, or minefields. Advantages are readily evident for providing accurate close air support for ground forces, reconnaissance, and approach and landing at airfields lacking instrumented ground approach aids. New tactics will evolve for use in blind and visually aided bombing, passive rendezvous, dropping supplies and troops with computed air release points, and controlling remotely piloted vehicles. In order to adapt these capabilities for possible NATO use, a memorandum of understanding was signed April 28, 1978, between the United States and 9 of the NATO nations: Belgium, Canada, Denmark, France, Federal Republic of Germany, Italy, Netherlands, Norway, and the United Kingdom. Never before had the United States permitted such direct NATO participation so early in the development of military equipment. But the reasons for this innovative step were compelling. NavStar bears the potential of enormous value to the North Atlantic Treaty Organization. Therefore, NavStar should benefit from the best of all available NATO skills and expertise. To bring this about, a NATO team headed by a NATO Deputy Program Manager keeps the Joint Program Office aware of NATO operational, technical, and logistical requirements, and conversely, gathers information which permits an assessment of the whole NavStar system from a NATO point of view. The team reports to a NavStar steering committee representing each of the NavStar NATO nations, which in turn reports annually to the NATO Conference of National Armament Directors. The steering committee meets twice each year to monitor NavStar progress and to direct and fund NATO studies and activities. In September 1979, during the semi-annual steering committee meeting in California, NavStar capabilities were demonstrated at the Yuma Proving Grounds, where much NavStar testing has occurred. Taking part in the demonstration were an F-4, C-141, and UH-1, all carrying developmental airborne NavStar receivers, 2 Army vehicles each equipped with a manpack, and an infantryman wearing a manpack. NATO's goal of rationalization, standardization, and interoperability has been acknowledged in the design specifications for Phase 2 user equipment, which required contractors to plan for a leader-follower concept during the production phase. That is, a contractor will qualify a second source to produce a given percentage of the total quantity of user sets. This concept makes possible the availability of a second or alternate source, if and when necessary. The possibility that this second source could be other than a U.S. firm has also been acknowledged by the Program Office and reflects recent initiatives in favor of the two-way street between American and European defense industries. Although NavStar is designed to satisfy firm military requirements, the system's potential in support of non-military affairs is equally impressive. Many military applications can be directly exploited for numerous purposes that have no military counterpart. Therefore, active liaison is maintained with the Departments of Commerce and Transportation, and the National Aeronautics and Space Administration. With Navstar, man takes another giant step along the road of technological achievement. With Navstar's economy, performance, and safety factors, man is converting another hoped-for possibility into a demonstrated reality. He is establishing a new constellation, 24 satellites, to write a new chapter in the story of navigation, a chapter of unprecedented precision, immediacy, and dependability. He is creating Navstar, the global positioning system.